So again, so we can have a conflict interfaces, right? If a class implements, like class allowed to implement more than one interface, like this class can implement two interfaces, and these two interfaces happen to have the same constants with the different values, or two with the same signatures, return type, then there's no errors. Like, for example, I have an interface named eatable. May I create a constant like int eat equals to 10, something like that. And I can create a method, but we just start eatable is create an interface turnable. Turnable, if I say int eat equals to 11. So now we have two interfaces. We want to prove this conflict interfaces, right? So if I want to have a class A who extends B and implements eatable and turnable, since it's allowing you to implement multiple interfaces, and we want to say, let's put that means of static void in string to call the constants, right? So a dot eat, right? We should be able to print out the values of eat because a has an access to the constant of interface eatable. But now a also have an access to constant of turnable. So that's why there's an error right there. Compiler is catching is ambiguous because they have eat that mentioned. So this is what it's talking about here. Have errors will be detected by compiler. Right? It's rare, but it could happen. Or two methods with the same signatures. Right. Now if we want to fix this, we can just remove that. Now it's happening. Right? When we run this, it's going to print 10. Right? Or like example of two methods with the same. So public, let's say int, return int, like, but it has to be implemented, right? In values, something like that. Let's say public can be omitted because it's always public. Now we can have different return types to method, right? Say it can be confusing, like this return double. Interface is fine. A happen to implement both interfaces. It's required to must either be declared abstract or implements, right? Okay. Implements the method values. Now there's a problem because it's confusing if I should implement returns what type, what double or int. Right, so compiler is complaining now. So if I say, okay, how about do both? Can we do that? No, it's confusing, right? Rule is already defined in A, right? So classes have same. You cannot do that. So to fix this, like I said, you have to fix the interfaces, or you should not implement both interfaces. That's one. Well, I'll just fix that, right? And like this, I'm going to have to make it like that. And this is double. Then now the compiler is fine, and A can do what we need, right? So that is what it's talking about here. Now, whether you use an interface of a class, like you said, we have to look at the relationships. If there's a strong relationship, like staff and person should be a class because staff is a person. Then we should create an abstract class, not an interface. But if you have a loosely relationship, like we were talking about, chicken is eatable, eatable is loosely, eatable should be an interface. Chicken is an animal, animal should be an abstract class. Or string is compatible, should be an interface. Now rational class. Oh, before we get to here, I want to mention this a little bit. This UML, if it's a UML, the dotted lines represent implements an interface. So interface not allow you to implement another interface. So this should be a solid. Interface can extend another interface, but not implement. But class can implement multiple interfaces. So this should be a solid line. And interface can extend only from one other interface. So we cannot do this. We cannot extend from two. Okay, so this is wrong for the UML diagram. So the rational class. So this is a class named rational, which is implements compatible and extends number. And rational pretty much just have the get numerator, get denominators, add, subtract, multiply, divide, right? And return the result as a rational back. And we have GCD, create common denominators. So this is just to show like rational is a class that being implemented as an example code here. Then GCD can find, return, get common denominators. So if you look at this code, construct with the numerator and denominators as constructors, and GCD pretty much just find, just loop through all the possible numbers that can be GCD with the algorithms here, like math, and return the GCD. And you can multiply and manipulate that rational numbers through these methods. Okay, and since it also extends the numbers, you also require to overwrite those two strings. Those int values, float values, just return the values as int, float, double version of the rational numbers. So designing a class should describe a single entities, and all the class operations should logically fit together to support a coherent purpose. Right, like for example, you want to design a class student that represents the student class, single entities, right? You should not combine students and staff in the same class. They should have separate classes. Student class, staff class. Because student and staff, they have different entities. So designing a class separating the responsibility, a single entity with too many responsibilities can be broken into several classes to separate the responsibilities. So string, class, string builder, string buffer, all deal with strings, for example, but they separate the responsibilities. So string class deal with immutable strings. That means once created can be changed, right? No, immutable means once created cannot be changed. But string builder creating multiple string, so you can change the contents, right? And the string buffer class is similar to string builder, except that string buffer contains synchronized methods for updating strings. So string builder, you can use it for any application, but string buffer, we use it when you want to implement program for multi-threads programming, or we call concurrencies, which you learned that in CSC202. When we write program for concurrency, we have to do synchronize. So concurrency means like when you try to access the object at the same time, right? So like when you program like client application, server client. Now when you write program in your computer laptop, it's only you access the application. But if you write program on the server, so it could be multiple users trying to access the instance of your object, like string name, like student name at the same time. Then how would you handle that? So you have to synchronize. So String Builder is the better way to support multi-threading. Like if I try to update last name of student at the same time, set last name, that's gonna be a problem, right? Like hundreds or thousands of students trying to update this guy last name at the same time, or parent of student and the student still and cousin of student trying to get in updates last name at the same time. You're not going to be able to support. So String Builder can support that with synchronized methods. You'll learn more about that into CSC202. Classes are designed for reuse. Users can incorporate classes in many different combinations, orders, and environments. Therefore, you should design a class that imposes no restriction on what or when the user can do with it. Design the properties to ensure that the user can set properties in any order with any combination of values. And design the method to function independently of their order of occurrences. Right, because user can incorporate class in different combinations, orders, and environments. So make sure don't make them related, right, when you design. No restriction. Provide public no-args constructor and override the equals method and the toString method to define the object class whenever possible. Like just show you that when I have circle class, I should define right and equals and compare to's, right? So compare to's, if a comparable, right, make comparable circle and define compare to, right? And also method toStrings, right? ToString of the circles. So just define them, right? Designing a class, follow a standard Java programming style and naming conventions. Class name should be capitalized, right? Method name should be lowercase. Data fields, lowercase. Always place the data declaration before the constructor, or the fields go first. Place constructor before all the methods. Always provide a constructor and initialize variables to avoid programming errors. So using visibility modifiers, each class can present two contracts, one for the users of the class and one for the extenders of the class. Make the fields private and accessors method public if they are intended for the users of the class. Make the fields or method protected if they are intended for extended of the class. Right, so fields will be protected. The contact for the extenders encompasses the contact for the users. The extended class may increase the visibility of an instant method from protected to public, or change its implementation, but you should never change the implementation in a way that violates that contract. Like you should not change the other way around, right? A class should be used the private modifiers to hide data from direct access by clients. You can use get method and set method to provide users with access to private data, but only the private data you want the user to see or to modify. A class should also hide methods not intended for client use. The GDCD as example method in the relationship class is private, for example, because it's only for internal use within the class. Using the static modifier, a property that is shared by all the instances of the class should be declared as a static property, like count, right, of the increment whenever you create a class objects.